centimeter, right?
Horse moves 88 meters like this, and while doing that, it sweeps an angle of 72 degree at the center of the circle.
Is it 220 by 5?
Then find the length.
Is it 220 by 5? So is it 220?
Take pi as 22 by 7.
So is it 220?
70 meters.
Sir, 220 by 5. 220 by 5.
220 by 5. Correct.
It was a what?
Take pi as 22 by 7.
God, dude.
Shadi, done.
Yeah, if you're taking this 22 by 5. So next one. So can we go to the next topic?
Wait, one more question to take.
So can you give us a very hard question this time?
How can there be hard question on this topic?
Yes. So basically, let's say the length of the rope is r. Okay. Can I say r 88 by r is going to be the angle 72 expressed in terms of radians? Correct? So from here I can get 88 by r. You can use 72 by 180 into 22 by 7 as your this thing. Yeah, so let's simplify. This will go by 4. This will go by 8, 20, 4, 10, 2, 5. Okay. So your answer will be, this will go by 2. So R will become 70 meters.
It's recording your head. Get up and see.
Correct? All good with the calculation? So there will be 7, 5 and 2 left over here, so it is 70 meters. Moving on, next question.
Bro, if elephants in the water don't
Listen to this question very, very carefully. For each natural number k, K for Kolkata, let CK denote a circle with radius k centimeters. For each natural number k, let CK denote a circle with radius k centimeters and center at the origin.
What?
Okay, fine.
So I thought it was CK and K, sir.
Can I repeat once again? Listen to this carefully.
CK meaning
people are talking.
What is CK? CK
You use the information.
circumference, no?
For each natural number k, K for Karnataka, let CK, Niranjan, CK represent a circle with radius k, same k, centimeters and center at the origin. Okay? So let's say I take k as 1, that means I mean to say there is a circle center at origin with different radius. So unit circle, correct? On the circle CK, a particle moves k centimeter. On the circle CK, a particle moves k centimeters. On the circle CK, a particle moves k centimeters in the anti-clockwise direction. Okay. After completing its motion on CK, the particle moves to CK plus 1. after completing this motion, its motion on CK, the particle moves to CK plus 1 in the radial direction.
CK plus 1 or CK plus 1?
It moves to CK plus 1. Next circle. For example, let's say I start with K equal to 1. It started here, it moves K centimeter, then it moves to the other circle. Correct?
And then moves K again.
Wait.
No, it moves. Yeah, it moves.
It moves to CK plus 1 in the radial direction. The motion of the particle continues in this manner. The motion, then it goes to CK plus 3, CK plus 4, CK plus 5, whatever.
Every time it covers CK plus 4 or CK.
Okay, I'll take an example. So many interpretations you are having that you are not using the context of the question. Let's say I am on the first circle, C1. I'll move 1 centimeter on C1. Go to C2, I'll move 2 centimeter on C2. I'll go to C3 and move 3 centimeter on C3. I'll go to C4 and move 4 centimeter on C4. Understood?
Until?
Now, the particle starts at 1, 0. So basically it starts at 1, 0. If the particle crosses the positive direction of x-axis for the first time on the circle CN.
Okay, so N will be 7.
Not if it crosses.
What?
I already gave the answer.
Oh wait, what? That's all.
If the particle crosses the positive direction of the x-axis for the first time on the circle CN, find the value of n.
If the particle
crosses what?
the positive.
How do you do it?
So if the particle crosses the positive
If the particle crosses the positive direction of x-axis for the first time, that means it takes a complete chakra. For the first time on the nth circle, that is CN circle, find n. To how?
It's easy. Basically what happens is that a radian is just a little bit less than 60 degrees. Now we know that if you go around the circle 60 degrees, 60 times in increments of 60, you will get to it after the 6th go. Now basically you have the radian being about 3 degrees less. So that means it is about a lag of 80 degrees. So that means that 7 circles will cover the lag.
You just have to find n which is slightly greater than 2 pi.
Yeah.
Natural number greater than 2 pi.
Oh yeah, right.
100. Now you tell me, while it moves on the 1 centimeter circle by 1 centimeter, how much radius is this covering at its center? 1 radian. Now again, let's say it's going in this way, 2 centimeter or 2 centimeter circle, then again how much is this? 1 radian. Correct? So basically,
2 pi radian.
after 2 circles, 2 radians is taken care of. And he has to again cross this positive x-axis, means he should complete 1 round here. Right? So let's say on the nth circle, he ends up just completing this round. That means he should have covered greater than 2 pi. So n should be greater than 2 pi. So which natural number is just greater than 2 pi? Pi is 3.14. So basically, which natural number is just greater than 6.28? So on the 7th circle, this particle will cross the x-axis once again. It took me so much time to read the question and this fellow did it in 2 seconds. Okay, anyways. Moving on. Guys. The class could be faster and more effective if the decibel levels are low. Again requesting. I know you all are very excited to learn new topics, but this excitement should not die out within 6 months. You have 2 years to go with the same exam. Can you run a marathon just like you're sprinting? You have to slow down a bit. You have to let go of your energy for some time to make it for the last moment sprint. So save your energy, don't burn yourself out right now. Moving on. This is the concept of trigonometric ratios for aligned angles. By the way, I don't want to take up basic trigonometric ratio identities proving that you already did in class 10th. R.S. Agarwal, R.D. Sharma, or those things I don't want to take up. Because it's just a waste of
See
time.
if this is proper. The camera is attached to it. Let's see if it's proper.
Now,
Stand up and see.
when you learnt these 6 trigonometric identities, ratios, sin theta, cos theta, tan theta and all, correct? Now, many people have this misconception that this particular ratios are actually applied only to a right angle triangle like this. Right? But in reality, we actually apply it to a reference triangle made from any angle which I want, and hence it can be applied to any triangle I want to. In fact, it is not dependent on limited to a triangle. I can choose such angles which go beyond 180 degrees as well. Okay? So first misconception that I want to break here is that trigonometry is applied to right angle triangle. Answer is no, it can be applied. These trigonometric ratios are equally valid for any triangle I want, and in fact it goes beyond triangles as well. Now why we only refer to such cases in our childhood days is because, let's say I take an angle like this, and let's say this angle is a part of this triangle. Okay, I'll get it. Now for this angle theta, if I say what is sin theta, right? Then normally to find such angle, we drop a perpendicular on this side extended. And for this angle, this becomes P.
And that becomes it.
And this entire thing becomes V. And this entire thing becomes H. Right? If somebody wants, he can solve the same problem by putting a perpendicular on this side itself. And he can call this as P. He can call this as V. And he can call this as H. So basically the ratio sin theta, which is P by H, is seen on a reference triangle that we normally make, which is actually a right angle triangle, and hence it gives us a feeling that trigonometry is applied only to right angle triangles, which is not the case. So if I give you any angle upward, you can actually make a reference triangle from it. So if I mention a triangle like this, an angle like this, let's say for this, can you find sine of theta for this? Yes, you can. Yes, you can. How do you make a reference triangle for this? You will make a reference triangle like this. Right? Are you getting this point? Now, in this particular segment, when I talk about P, B and H, remember a few things. P and B are directed line segments. When I say directed line segment means
Basically,
they will have signs.
so they're vector,
Right? Correct, kind of. Where H is something which is always positive, that means it will always have a positive sign. So what I want to say is that you can have your P, B as positive or negative, but your H will always be positive. Now why I am telling you this is because, first of all, why are we converting things into radians? Do you know that? So that we can express those angles. Yes, we can express those angles using our coordinate axes where we mention things in terms of real numbers. Right? So, Now I am going to tell you which is very very important, and if you master this art, then you will be having a lot of comfort dealing with difficult level problems on this topic. So please note this down. Base, perpendicular, both are directed segments. They have signs, right? And hypotenuse is always positive because it is under root of p square plus b square. We discussed in the bridge course under root of
the very first class.
Yes. Now why I am telling you this is because of this reason. When you actually talk about any angle theta, okay, let's say I take an angle theta. Okay, what we do is we make our coordinate axis pass through this in this way. That means we always consider the meeting point or the originating point of the ray to be the origin of the Cartesian coordinates. Correct? All the measurement of angles would start from the positive x-axis. So this will always be your initial part. So if you want to measure any angle, let's say 30 degree, how much will you go in which direction? 30 anti-clockwise. If I want to go minus 60 degree, in which direction will I go? I'll go
60 degrees
60 degree clockwise. If I want to measure 450 degree, how much will I go?
450 degrees.
By full rotation and this. Are you getting it? So basically, by rotating this ray, you are generating any possible angle that you want. Correct? Now, on this coordinate system, I will start talking about trigonometric ratios for all the angles that you are going to come across. If I say, what is the trigonometric ratio sine for 30 degree? Let's say I want to find sine 30 degree. Okay. So what we do normally, we construct a reference triangle here. Okay. Normally in school they say keep this as unit. Okay. And make this as half. Correct? But note this half is in the positive direction of y. Are you getting it? You can keep it anything you want. You can keep it p and you can keep it h. Right? So if this is 30 degree, you would realize that p divided by h, where p will be positive and h is always positive, will result into sine 30 degree, which is actually half. Okay? So P here is positive. The reason is I am measuring it along the positive y-axis. Are you getting this point? If I ask you what is sine of minus 30 degree, then you will make a similar triangle like this. But now you will realize that your P is measured in which direction? Negative y direction. Right? So sine of minus 30 degree would now become minus half. Because this was 1, this was 2 in the case of 30 degree, but now this will be minus 1 and 2 here. And hence I use the word directed segments. Are you getting this point? So if I give you any angle, right, will you be able to make a reference triangle, and will you be able to identify what would be the sine of that angle? Yeah. Sine means S-I-G-N. Okay. For example, Asha, let me answer this question.
So, why doesn't the hypotenuse change?
Again, hypotenuse is under root of p square plus b square. So p square plus b square, under root is always positive. Under root of any quantity is always positive.
And square sum is always positive.
Huh?
When you take the root of something,
A root? What is root of 16?
that's what I
No, it's just 4. Hypotenuse is always positive. Is that okay? Alright. Now, let's say I go to 150 degrees. 150 degree, you all realize will be like this. Correct?
The other thing.
So if this is 30, this will also be 30.
Oh yeah, and so will have the same
So this
side.
will be 150 degree, correct? So now if I ask you for this angle 150 degree, tell me what is sine of 150 degree. You will say very simple.
Sine 30.
Let me make a reference triangle like this. So basically you will construct the right angle triangle like this. Correct? Do you also realize that this triangle will be exactly congruent with this triangle? So if this is one, this will also be one. Positive one or negative one?
Positive one.
Positive. Because you're measuring, see everything has to be measured from this direction. X6, your all the measurement has to be done from origin onwards. So this is positive x, this is negative x. This is positive y, this is negative y. So this one will be the same one with positive sign because you are measuring it along the positive direction. Correct? Hypotenuse will be 2. So even for sine 150 degree, your answer will remain to be half. What the what? Now let's go on to 210 degrees. That means let's cover 180 and then 30 more. Now if I ask you, what is sine 210 degree?
Minus.
Minus 1 by 2.
Now note, we have already crossed 180 degree. So that breaks your another myth that we cannot find sine of such angles which are beyond a triangle. Now we are already beyond a triangle. 210 degrees more than 180 degree. Here if you make a reference triangle, this will be your reference triangle. Are you getting it? Now, what is, can I say that this triangle will exactly be congruent with this triangle again?
Yes.
So if this is, I'm sorry. If this is 1, this will be 1 but with a
Minus.
negative sign. The reason being I am measuring it below the x-axis. It's negative y direction. Right? H will be still 2. H will be still 2. So what is my answer going to be for sine 120 degree? Minus half. Are you getting this? Are you getting this? Now let's take another angle. I made a full circle and came here. How much angle is this?
Isn't that just minus 30 degrees?
Same as minus 30 degree, or I can say it is 330 degrees. Now what is sine 330 degrees?
Minus 1 by 2.
You will say minus 1 by 2, which was same as sine minus 30 degree as well. Do you realize that? Now these angles that I was talking about, 150, 210, 330, and further on I can go to 390. Then I can go to 510. All these angles are called allies of or allied angles of 30 degree. So this is the topic name that we are going to talk about in this present segment. We are going to talk about trigonometric ratios of allied angles. Allied means, you know the literal meaning of allied? What was correct? So 150 is an ally of 30.
When it's even,
210 is an ally of 30.
What?
Why are you saying right angles?
When it
Because
is even,
when we
for
were
sine
young
it's 1.
in class
Sine
10,
of
we
n by
already
2
knew
is
about 30,
n. And for
45,
cos,
60, 90,
it's odd.
right? Now the time has come that if there is an angle which is related to 30, related to 45, related to 60, related to 90, those angles will be called as allied angles. Are you getting this one? Now in the very same example, I would like to find cos 30 as well. Let's see. Start with this triangle. By the way, this is 2, this is 1, this is root 3.
So it will be
Correct? Now, call it plus root 3. So cos 30 degree will be plus root 3 by plus 2, which we know all is
not
root
this
3
one. I'm
by 2.
talking about.
But what about cos 150
See,
degree?
this is 5. No, this is 0.
Minus root 3 by 2. So cos 50, sorry, cos 150 would be minus root 3 by 2. Understood?
Talking when it's n
What will
by
be
2
cos
and
210?
n is even. Sine of n by 2 and sine is even. N is even. What is it?
Minus root 3 by 2 again. Because base is still negative, hypotenuse is positive.
1 when it's 1.
What is cos 330?
When it's
Same thing as cos minus 30
it's
plus root 3 by 2.
Yes, this time you will say root 3 you're not paying attention now, I'm seeing the class 12 people struggle with this.
So we learned it.
Yeah, they do. When I do inverse trigonometry with them, they give a lot. In the inverse trigonometry, what will happen? No, I'll tell you. There is sine of some angle is minus half. Tell me the angles. Ulta I will do.
Because they would have forgotten.
So please be aware of this so that we can understand the later chapters of trigonometry well. Let me complete. What is cos 210? Sorry, tan 210 degree? 1 by root 3 because it is minus 1 by minus root 3. Minus minus goes off. What is tan 350? Tan 350 will be again minus 1. Is this clear? Is this idea?
So we just stick up the slopes, right? So all that we need to do is just see if it's part of the number, sloping on a number, sloping line.
Correct.
What is speed now?
Now,
She's just trying to get every sign
that's what I'm coming to. Now you would realize that the signs that you were seeing, SIGN signs that you were seeing, whether it was plus, minus, it was varying as per the quadrant for different trigonometric ratios, right? In the first quadrant, you would realize that all the trigonometric ratios were positive because P was positive, B was positive, and H anyways is positive.
ASTC.
Correct?
Yes, we see.
In the second quadrant, you realize that only sine and its reciprocal, which is cosine, is positive. The reason being, P is positive and H is positive over here. So any ratio formed from P by H will be positive. So here sine and its brother cosine, they are positive. Okay. In the third quadrant,
Tan and
this
cos.
is your second quadrant.
Tan and cos.
In the third quadrant, you would realize
Tan and cos.
P and B both are negative. So the ratio of P by B, whether you talk about tan or cot, both are positive. Okay? And in the fourth quadrant, you would realize B is positive and H is positive. So any ratio made with B and H, which is cos and sin, they would be positive. So this is the sign scheme of any trigonometric ratio for any angle that you would come across. So all you need to know is the quadrant in which the angle lies and which trigonometric ratio are you dealing with. So quickly asking one question, Khushi, what will be tan of any angle falling in the fourth quadrant? Sine negative or positive? Right? This rule is better learned as a lot of mnemonics. Many people say after school,
all schools to college.
college.
All schools like cash.
Oh yeah.
Avye, no, sorry, Gaurav. All strippers like cash.
Add sugar to coffee. Right? After school to college, after school to CENTUM, whatever. Correct? Is it okay? Clear? Now, this brings me to finding the trigonometric ratios for various allied angles. Now I will start with positive allied angles. Later on I will talk about negative allied angles as well.
Yeah.
All of you understood when I say ally, what does it mean? 120 is an ally of 60. 60.
It is a right?
We say 180 plus minus or 360 plus minus. Okay. Okay. Now we'll talk about trigonometric ratios for various allied angles. Listen to this concept very, very carefully. If you miss out here, you'll have a lot of problems. Okay. Keep back your phones. If you want to find trigonometric